Consider a setting with two alternatives. For example, Alice chooses between taking the bus, alternative number 1, or some other way of getting to work, alternative number 2. Let yn equals 1 if Alice chooses the first alternative, the bus, and 0 otherwise. Now suppose that our model of representative utility is Vnj equals Sn prime multiplied by gamma j. In other words, suppose that the representative utility depends on decision-maker attributes only. As we discussed in an earlier video, only differences in errors matter for choices. So let's suppose that the difference epsilon n2 minus epsilon n1 has a cumulative distribution function capital G and is independent of the attributes Sn. Subtracting, we find that the utility of the first alternative minus that of the second can be written in the following form. Simplifying, we obtain Sn prime times a parameter vector gamma that is defined as the difference of the parameter vector gamma 1 associated with the first alternative minus gamma 2 that associated with the second alternative, plus the difference of error terms epsilon n1 minus epsilon n2. Since Alice chooses alternative 1 if and only if the difference un1 minus un2 is greater than 0, the choice probability for this alternative is given by the following expression. The probability that yn equals 1, given Sn, is equal to the probability that the utility of the first alternative minus that of the second is positive, given Sn, which is equal to the probability that the error associated with the second alternative, epsilon n2, minus that associated with the first, epsilon n1, is less than Sn prime multiplied by gamma, given Sn, and by our independence assumption, along with our assumed CDF for the difference of errors, this is just equal to G of Sn prime times gamma. If G is the standard logistic CDF, lambda, this is precisely the logit model that we examined in an earlier lecture. If G is the standard normal CDF, it's the probit model. A few moments ago, I assumed that the representative utilities only involved decision-maker attributes. When there are only two alternatives, however, we can actually convert attributes of the alternatives into decision-maker attributes in a relatively flexible way. So suppose that we have x1n, a vector of attributes for the first alternative, and x2n for the second. Then we can construct Sn to be the difference x1n minus x2n, and this difference does not vary across alternatives. For example, suppose Alice is choosing between taking the bus and driving. If T-bus and T-car are her door-to-door commuting times for each mode of transport, then we can allow the representative utility to depend on the difference T-bus minus T-car, because this difference is a decision-maker attribute. It doesn't vary across the alternatives.